In this question, it says, using algebra, prove that given any three consecutive even numbers, the difference between the square of the largest number and the square of the smallest number is always 8 times the middle number. So let's first write our consecutive even numbers. So first even number I'm going to assume is n. The next consecutive even number would be n plus 2, and then n plus 4. So since it's an even number, so we add 2 to each consecutive number, because all even numbers have like a difference of 2. So what we do next is that we make our equation. The difference between the square of the largest number, so that's going to be n plus 4 whole square, minus and the square of the smallest number, so that's going to be n square, is always 8 times the middle number. So 8 times n plus 2. So let's expand n plus 4 whole square. N square equals to 8n plus 16. So n times n plus 4, n plus 4 times n plus 4 minus n square equals to 8n plus 16. So that's going to be n square plus 4n plus 4n plus 16 minus n square equals to 8n plus 16. So when we simplify the left-hand side, we can see that we're getting 8n plus 16, which is basically the same as the right-hand side, which means the algebraic proof stands true.